Okay, good morning. Can I have, so those in the back, can you guys read properly? Okay, I shouldn't put the lights down. Okay, good. So this is COM 401. There are two sections, 001 and 002, and this is the 002 section. And my name is Prasun Devan, and hopefully by the end of the semester I'll know some of your names, if not all. So what I'll do today is, as this title of this slideshow shows, talk about what to expect in this course, both in terms of the contents. So I told you this course is unusual. You know, maybe NCCA does a pretty good job of doing the same thing, but we are going to do a very intense project, or at least large project. I won't say intense. So there's really no textbook. One of the students mentioned KMP. He's the other instructor who teaches this, and neither of us uses a textbook. And this course has been taught before I came to this university, and it never has had a textbook. Okay, and the course has evolved. So it used to be taught in a language called Turing, and I made it in Java, so there's no really standard way here. So you will have the PDF of slides. Anybody who's gone to my webpage will see that there's a PDF. And this is the most popular way that people use of learning, because you can just click on it and see it. And one advantage of PDF, this is a disadvantage also, is that since it doesn't have all the information, you fill in the gaps yourself. And the more gaps you fill, the more you learn, the more active learning you're doing, right? So sometimes a bad teacher is a good teacher because they're forcing you to think more. Somebody who tells a very logical, great story, you keep going, and you don't maybe, it's like a mystery story. They try to confuse you a lot. Okay, they give you the wrong clues, but you're constantly solving the problem, and ultimately you kind of remember the plot, rather than, just tell you the butler did it right at the beginning. So sometimes that's good. Okay. But you will also have PowerPoint of slides. Okay, so you can, at least one person I hope will use it, because I keep putting this link in. And if you notice at the bottom right, there's this icon. And anybody know what this might mean? Yeah. I added my voice to the slides. Okay, if you notice here on the top left, it says, it tells you I'm recording. Right? So everything I'm saying is being recorded. So I don't need a special video camera to do the recording. The recording won't get us, but it'll get at least my voice. And if you guys speak loud enough, yours too. Okay? Or if I repeat the question. So how can you use this? You can go into slideshow mode, and it'll just be animated with recording video. Okay, so you don't have to go to YouTube. You can just go and start slideshow, and you can resume it. You can stop it at any time, get out of the mode, and start it at any time, and it'll just play everything with the animation and voice synchronized. Okay, so this is something Microsoft has, and I've actually spent some time there. And even in the Office group, many of them don't know what the potential here is. So it's a very it's not well exploited by even the inventors of this tool, and certainly not in education. Okay, so I always try to tell my fellow teachers to use this facility, but most people don't tend to do it. And the thing is that if you notice, I like to come here, but I very quickly when I'm speaking come back here because I want it recorded. So you can't just wander around in class. And that's a disadvantage. Okay. Now, if they can go and play it like this, they can probably create a YouTube video out of it too. So the problem with this is that you've got to download the PowerPoint, play it, and so it's multi-clicks. So by the way, you can get out into unsynchronized or no audio mode. And by the way, if you want to listen to this on your smartphone, I have an Android. And there's a tool called WPS, and that one will play the recordings. Not all PowerPoints will play the recordings, but that's one way. So what you can also do is, And this is what, my students who've been using this in previous semesters said, "Hi, I wish you told us this before, this earlier." Even when you're not in PowerPoint mode, you can just click on this and listen to the voice. It won't be synchronized with the animation, but the advantage here is that you can go and fast forward, and you can go to randomly access any point of the recording. You don't have to go through the whole recording of a slide. Okay, so that's another capability you have if you go into that mode. Okay, questions so far? So, if Microsoft can go and do this with PowerPoints, it can probably create a video file that can be uploaded into YouTube, and it does do that. Okay, so and now you can go and randomly access any part of the video without having to escape in and out, and you can play at 2x because audio at 1x is rather slow. Okay, and a lot of people use this. Okay. Now, we have a little trade-off. With PowerPoint, I can go to any slide and go and understand what happened in that slide. Okay, it is structured by slide. And here, you can fast forward, you can go forward and back in time, but you can't go to a particular slide. You don't have a table of contents of slides and go to a particular slide and listen to it. Okay, so it's not a structured video. It's unstructured video. It doesn't know, the video doesn't know it came from PowerPoint. Okay? So if PowerPoint can create this, if Microsoft can create this, it can probably create something that allows both. Okay? And it did. Okay? And that's called Office Mix. Okay? And if you notice that this is also something that you can play, it's got a button that says play. And you see these markers at the bottom. These are slides. Slide 1, slide 2, slide 3, slide 4. And you can go to any of these markers to go to the appropriate slide. And you can also go to table of contents and get all the slides there and just go to a particular slide and listen to the video. Okay? So you will see that for each topic I have Office Mix, I have YouTube, I have PowerPoint, I have PDF, I have all of these facilities. Okay, questions so far? Now, for some reason, students don't tend to use this. Okay? And I don't want to press too hard, because like I said, I spent some time in Microsoft and actually had a little bit of hand in this. So, maybe I'm too biased. But I think this is great. But people tend to use YouTube. Okay, that's just because maybe it's more familiar. Okay, now, this is not the kind of videos that were created for flipped classes, where you just speak to the camera in a very short 15-minute. So it's if you think of a concert, it's not a recorded concert, it's a live concert that's been recorded, not a studio recording. Okay? And I've actually tried to create such videos, and there was a time when I was, I was very nervous about going in front of people, and I was better off without people. But now I can't just talk to the computer, so it's much easier for me to give a lecture here and get it recorded. I'm more natural that way. So, so this is not specially meant for a flipped class. This is just the whole video that is recorded. So you will get all the questions there, which I think is good because that makes you think. And there may be long pauses while people are thinking of the answer. So again, you should think of the answer that time. And you typically cannot hear the student answer. I try to repeat the answer in some way or the other, but maybe I don't. But you can fill in the gaps. I've listened to these videos, and a year later, and a lot of students have used this, so it does work. Okay. But audio is not the fastest way to get information. That's why you go to 2x. So wouldn't it be nice if you also had, like a biology teacher, the text? And that's what I first did when I started teaching this course. I first created some documents, and they are available to you also. And then I created the PDF, PowerPoints. And PowerPoints, are the ones I presented, so they kept evolving, whereas this text kind of remains static, like a textbook. Textbooks are always a little out of date because they're behind them. So, so there are lots of typos there because it was not, it's not really a textbook, but there are students who use this resource a lot. So I want to, this is a useful resource if you don't want to listen to a video, and this is random access. It's much more random access. You can search for text. So that's yet another alternative you have. Okay. And what I also did was convert the Word documents into Google Docs and make it available to you so you guys can read this and comment on it if you have questions and correct things. I think in the beginning 1 or 2 students used this facility last time, but I encourage you to use it if you have time. So that's yet another mechanism available. Okay. Now, you mentioned that you'd like source code. The source code is also available as HTML links. And it's commented on top of the comments later too. So if you want to just learn from the code, okay, that's the best. That's even better than PDF. You look at the code, you try to understand it yourself, and if you can, you don't even need the PDF hints, and you're learning much more. Okay, so people have used this also. So you can go. This is just web links. They're static links. You can't execute the code. This is just code as readable text. Plus, how many of you have? Some of you have used Git. How many of you? Okay, I think I did a survey. Very few of you have used Git. So Git is a way to get shared code that is shareable by the whole world. Okay? So all the code that I have is also shareable that you can go and import into your Eclipse project. In fact, how many of you have been able to get Java? I asked you to do that if possible before today's class. How many of you have successfully gone and imported the Git project into Eclipse? A few. Oh, good. Rest of you, how many of you have tried and had trouble? A few of you. So please use recitation time or maybe an end of class today to get that sorted out. So this is something I'll encourage you to do. And so you can actually import all the code into your Eclipse, experiment with it, change it, and look at the comments. And that's yet another way to understand this. Okay? Questions so far? So, sometimes choice is bad because you have to think, and as an engineer, you're always trying to optimize. So sometimes it's good if you have just 2 cars to buy. To think about which car to buy, and so. But you have a lot of choice, and I've tried to tell you the pros and cons, and depending on when you're looking at the material, maybe you will look at PowerPoint in the beginning, maybe look at the PDF before exams. So it's not as if you're stuck to one mode. Okay. I did a survey last time, and almost everything was used to some degree by some student. And like I said, for each topic, I had links. So scanning is the topic. I have the PowerPoint, the PDF, the YouTube, the mix, the Word file. Okay. If you read that stuff and you find mistakes, please let me know. And I'll correct them too. I will spend some time this semester trying to update those docx files if I get time. The PDF of the docx, the Google Docs in Drive. I also have sometimes animations that I've created, videos I've created. So scanning visualization is an animation I created for the scanning part. So sometimes I have that. Then there's the assignment next to it. And on the right of it is the link to the code on the web that has the source code on the web. Okay, I told you that all the source code is linked on the web. So you have that. Questions? Okay, so I've told you what resources we have. Whether we do flipped class or we don't do flipped class, we have these resources. Now, given that we have these resources, the question is which one should we go to, regular class or flipped class? And I have some typos there I have to correct. Now, if we do believe that concept-heavy subject should be maybe taught in lectures and sort of more applied stuff should be done in flipped class, we don't quite know because this is applied, we're talking about programming. This is not your programming 101, this is programming 102, so maybe it's got concepts that you do need to internalize, and so maybe we don't quite know what to do here. It's in between. But it's hard to argue that with resources, a live lecture is less useful than without resources. Okay? If I didn't have all these resources, I'd better have a live lecture. Okay? So with resources, the value is a little less. I don't know how much less it is, but certainly that's an argument saying that maybe we should do something that's flipped. Okay? So if we do flipped classes, what do we do in flipped classes? So I'm just curious again. Math, what did you guys exactly do in the flipped class? I know somebody was here. Somebody here said math. Yeah.
So pretty much, it was a little different with the class. Sometimes we would have an in-class lecture. But if we did, one of the students would actually do it, so they'd have to make a lesson plan. But it was so the teacher could have a little more input on it. But effectively what we did is we would go out, but we had a textbook. So we would take notes out of the textbook, and if we had any specific questions or examples, we would talk about that in class specifically. But if we didn't, we'd do more sort of applied work with it. What we would normally do kind of for homework. But then we would have additional homework on the side of that. But effectively, it was just like really learning the fundamentals of it outside of class, but then learning the conceptual application of it almost. That wasn't in the textbook as much in class.
So basically, whatever was in the textbook, why repeat that in class and do some problems in class that learned in the textbook and have some interaction and also have some students maybe take the lead in. And so why were you one of the people who thought it didn't quite work well?
Yeah, I thought it was easy to get lost.
Easy to get.
The only thing is those are really small classes, we got more like one-on-one attention. But really, first of all, it was math that was a level over our heads because we were taking difficulty without having to take calculate. So we didn't understand some of the fundamentals of it. But it was hard to sort of make sense of some of the more important topics that kind of were brushed over on around. But in the end, it worked out. We didn't have an exam. We probably all would have failed.
Oh, you didn't have an exam?
No.
It was an undergrad class?
This was actually in high school.
High school, yeah. We are required to have a final exam.
Yeah.
So
Yeah, we just, he was like, you're going to retake in college, so don't worry about having an exam.
Okay. And the chemistry class, some of you talked about the chemistry class. What did you guys do? Yeah.
I did classical chemistry, but we basically she recorded lectures, we watched them at home, and I was to get the basis. And then if we had questions, we could bring them in class. But really, class time was to do kind of applied projects, and so then you could have help there while you're doing your projects, rather than being back at home or whatever and having to look through those resources. You could have help as you came across those problems. Because in a lecture, you're listening, you're like, oh, I think I get that, but you don't really know what you know until you start.
I love that sentence. You don't know what you know until you start applying. It's lectures. I mean, lectures are very easy for me. I've been doing that for years, and it takes time, by the way, each time you teach the course. But you kind of think, oh yeah, they got it. The students think they got it, and then the real truth comes out in projects or in exams. So that's why people are going towards flipped classes. So what do we do in flipped classes? Problems related to homework, or maybe the homework itself. Okay. And I asked students last time, and they said, and this is good when you can, when maybe this is not phrased right, but when a small amount of work can convey a lot of concepts. Okay. Because you can only do a small amount of work, and you're trying to get some concepts. But we're talking here of taking small amount of things that may or may not be hard, but putting them all together. So we're talking about creating a big project. So if you're creating a big project, you better have classes that build on other classes before that, and then you have all these dependencies. We already have the dependency in assignments. We have that dependency here too. And another problem with this is that already the programming effort here is high. Okay, like I said, somebody told us that this class is the 4th hardest class in university. So if I add even more work to your plate, you have only so many cycles. Okay, and we have recitations where we're going to do a little bit of this stuff. So maybe we should do that in lectures also. Okay. So what can we do? As was mentioned, we can just do the homework here. Okay, and I really, really wanted students to do this, and I still want you guys to do that. But when I talked to students, they said, you have to think hard. And I can't think with all this noise around me. I need to have my solo time to think. Okay? And yeah.
When you say homework here, you mean taking input from us and us spreading on a group, or all of us working together, telling you or asking you how we can write the program out?
I'm talking of you actually doing a solution right.
So there was a solution right here.
And as the problems arise, you ask.
Oh,
Or you could, in groups, talk about how you attack the problem. Each one of you has to submit your own solution. You can't have code duplication. That's your part. So you can talk as much as you want to before that, but we can't have one solution for 10 students or even 2 students. So discuss how to approach the problem. When you have problems, raise your hand. So that's what I'm talking about. Any help will help. Other questions? Okay, so with homeworks, should deep thinking be done solo? Maybe. And limited discussion with classmates. I'm glad you want to talk to classmates, but most students, they just, they all want to work independently, as it turns out, at least in computer science. So I keep encouraging people to work together, but they tend to do it. And if you're going to take the exam, you should do some work alone, at least the coding you have to do. Okay? So, we are not quite sure what we should do in flipped classes. So let's try to go and see non-flipped classes, and maybe and see what we should do in such a class. Okay. So I can go and present a PowerPoint with all the concepts. Okay. That's one way to teach. Anybody else had a non-flipped class where you did something other than use the whiteboard or have a PowerPoint? Was there any other way you learn programming in class? So one is to have a lecture with either the whiteboard or PowerPoint. Any other way to have to present a lecture? Yeah.
My previous class, we would just follow along as the professor typed the code.
You would follow along as the professor typed the code. Okay. So I could open up Eclipse and start coding. Okay. And how many of you have had a class like this? So, what do you guys think? There's no perfect silver bullet here. So, what are the pros and cons of these two techniques? There's only a few of you who raised your hand. That means most of you had, these PowerPoint or whiteboard lectures. So, what do you think? Yeah.
So where I thought was that when we were programming along with the professor, it was more like we would wait for the professor to finish typing and then we would do it rather than coming to it on our own. So like for students it's a good thing and you don't have to think too much during class, but then later after class it tends to be a problem.
So what you're saying is that you were like the person sitting in the car, watching what's happening.
Yes.
You weren't driving. And so when you had to drive on your own, you needed a GPS or somebody else, right?
Yes.
Anybody else? Yeah.
I think that if you record your code, anyone who needs to look at how you code could watch that, but it's probably not worth class time for you to code for us to wait for you to finish coding.
So wait for me, and I am not a touch typist. Okay, so I am the worst guy in the world to do it. But even if I was a touch typist, apparently that's still a problem. But yeah.
In my class, the professor he had the code already made, but he would kind of write it for us in separate files all the time, and then copy and paste it into the thing when if as a class would give the info. This is what we need to do.
Okay, so one way of teaching is that I type and you follow along, or you just follow me, or you retype it. The other is I type something and then ask you what the next step should be. And then as a class, you come up with the next step, and then you sort of show the real solution, right? And that's a little bit, it's still slow, but maybe you'll retain that a little better.
I see as a concept is that if you are doing live programming, the amount of creativity gets subdued a lot. And two, even if we are doing that, okay, as a class, tell me the next line, the class comes up with one solution instead of everyone coming up with their own unique solutions. Also, everyone does not have the same programming style or the same way of programming, so that gets affected if we do live programming.
So if the problem is very constrained, and there's only one next line, it makes sense. But when there's so many paths to diverge, then we just go along one path and so that becomes a problem. So as long as, and so we're talking of intermediate programming here, where things are going to be less constrained than in interprogramming.
I was in a class where the professor would type whatever the students suggested.
Yeah.
So even if it was wrong, we type it and then we talk about why it was wrong.
Right. So that's good. That solves that problem. It maybe slows down the concepts, but you really understand things well because you see all these ways.
But you can't see all the ways, right? Because 3 or 4 is not the only way. They can
Okay.
maybe 50, 60 ways.
There may be 50, 60 ways, good. But when the problem is constrained, there's probably only, okay? Yeah.
I found that style is a lot more useful when introducing a new programming technique because you might not have seen it before. Just watching pieces go together and watching what happens when you go through each step is a lot more helpful
Yeah.
than just seeing it on PowerPoint.
So PowerPoint gives you the static, whereas that gives you dynamically how the person's mind is working and so forth. And did you guys learn some programming environment commands in the process? When you dynamically create something, you get to see, oh, you can copy and paste. Everybody knows that. But maybe you can just Control-Shift-F and format things. This is how you debug. Okay? So, how many of you use the debugger? Just a few of you. Okay, now I can't program without a debugger. Okay? And it's very interesting. You would think that, given how long I've been programming, I would be a much better programmer than you guys. But because I know how to use the debugger, I don't think too hard before writing code. So I see students come in and their solution is not at all, their program is not working at all. And we figure out what that one problem is, and it all works. And I said, wow, with one correction your program worked, because they ran the program in their head about 10 times because they didn't know how to use the debugger. Whereas I say, why should I run the program in my head? I can just use the debugger. Okay, so you become a bit of a hacker when you know the debugger. But you can't really do big programs without a debugger. So one of my big goals here is for you to use Eclipse in a very fruitful way. Okay? That's what you will be doing after at work if you join industry. And so that's something you get to see when the professor does live programming, because you get to see what commands they use. Okay? So there are trade-offs, okay, and that's why different people use different things. So slides are faster paced, okay, concept intensive, and you can use animation and graphics, whereas with code you just got text there. Okay? And you won't find a compiler class being taught this way. Like Nirshad mentioned, that when there are alternatives are so many and the program is large, you're not going to have a professor write a compiler in class. You just can't. Okay, you can write some toy programs. So again, we don't know whether we are advanced or whether we are beginning, and so that becomes a little bit of a problem. And live programming is slower paced, so it may be too slow, but at least you understood. If you weren't just blindly following what was happening, you understood to some extent, and you learn programming environment commands, and it's used for intro classes but not for advanced classes. So now I've told you all the pros and cons, and now let's start to make some decisions here. Okay? What if we do the following? Rather than I code in class and you watch or you change or whatever, when I do that, I better have prepared the class. I better have a script in my head where I'm going to figure out what code we're going to change, what questions I'm going to ask you. I'm not going to ask you to fill in every blank. I'm going to ask you to fill in blanks that are interesting. Okay? So you learn more as a driver than as a passenger. So what about, rather than, I really meant to say that you learn more as a passenger than a driver. Okay? So what we'll do is, we'll make you more a driver. So somebody mentioned comments in code. So what happens in a PowerPoint presentation? I have code in a discussion, in a PowerPoint. Okay, so I embed relevant pieces of code there, and I go and animate the discussion and say, okay, this is what this is giving, this concept is being highlighted here, this concept is highlighting here. So the primary thing is the presentation, and I've got code embedded in it. What if I do the opposite and embed the script or the discussion in the code? So rather than you watching me, you just follow the steps that I'm supposed to do. So you get to actually type in things yourself. It's going to be slow at your speed, but everything you're typing in, and so you're hopefully learning a little better. Okay, so you're getting that benefit as a driver. It's still slow, okay, and it may be too slow for you, but at least you're the driver, not the passenger. Okay, so that's what I'm calling a praxis. And I've done this for every problem that I've got. And talking about multiple solutions, so there in the instructions will be, change this code this way, see what happens. Okay? change this code in this way. What do you think is the alternative? What do you think is the pros and cons of doing so? So there's a whole discussion here, and you tend to sort of, now we're getting into a flipped class mode. Okay, we've taken the idea of live programming in class and turning it into a flipped class, and it's also flipped in the sense that the discussion is in the code rather than the code in the discussion. Make sense? Questions? Okay, you will get to know this when you see this. So that's basically it. This is a lot of work for me, okay, because it's easier to sort of just have a script and follow it rather than embed it all in code. But that's you start with the program template and you start modifying it. So concept presentation in code rather than code in concept presentation. And we'll have we want to make sure that, in a real class, I'll ask you questions, you answer them, I'll hopefully record that somewhere, and we have participation. So we do want to make sure that you thought about what you did, rather you didn't just follow. So we'll have a quiz, Sakai quiz, where you will actually give in the answers. Okay? Now that quiz is it's going to be mostly at the conceptual level. That quiz you can answer without doing the praxis. So if you're fine with the video, if you're fine with the text, with the notes, you can just go and use those to answer the questions. You don't have to go through. This is yet another mechanism. This mechanism is fraught with more problems because something might not work, you might not follow the instructions right. So this is where we'll provide you with help. Okay, this will require more help than, because this is hands-on programming, it will require more help than you're just watching a video. Okay? But there's no requirement that you actually go through this mechanism. All we want is the quiz to be done, the questions to be solved, answered. Okay? Okay, so that's human help. This is the world of automation. So the question is, can we get help automatically also? Okay? And is this a concept you've seen before you came to this class? Software tools helping you? Answering questions for you? Telling you where you're wrong? One person is saying no, one person is saying yes, okay?
So it wasn't for Java, it was for C. I know it'll if there's an error, it'll tell you, did you mean this or did you mean that?
So if there's an error, who will tell you? The compiler. Okay, and if the programming environment is nice, it will provide you with a little bit better message. Absolutely. Okay, and the compiler will probably be more correct than a human being may be because it knows the exact rules. So got the wrong one, but that's okay. Hopefully we'll last. So my laptop doesn't have a very long battery, so we'll see. Yeah, we'll see how far we get. That's one thing. Anything else you've seen in this class where some automated tool has helped you?
Like the run checks that you provided with the assignment, I found that really helpful.
You found them helpful because?
Yes, it was great to see everything going.
So sometimes people come to me and say, "Am I on the right track?" And that tool tells you if you're on the right track, right? So that's that. So those also. So the Praxes are meant to actually. So what you mentioned was the compiler and programming environment, and that's part of the reason why I'm using Praxes, because I want you to be able to get help from the tools. So what's the job of an instructor, a teacher? Is to help you learn topics or help you learn how to learn. Okay, so I want you to help you learn how to learn. Okay, so if you start using the programming environment and many of you haven't really scratched the surface also of what help the programming environment can provide. So that would be good. So these Sakai, the Praxes are meant to sort of formalize the help you can get from programming environment. So for instance, if you want to know what operations you can do on a string. Okay, you can just go and say, you can just type string dot, and it'll go and tell you, okay, char add, chars, char code point, all these operations available. Then you can go to a particular operation and go and read the whole documentation of it. Okay, so the programming environment is providing you with information. You come and ask me what char add does, maybe I'll make a mistake. But this is going to be more precise. Okay? So in the Praxes, I'll often tell you, okay, hover over this operation. Go and read the Java doc of it. Do this operation to visualize the data structure. So, so programming environment, and you might have seen already that if you try to make a mistake, it goes and says, sorry, you can't convert from double to int. And it'll tell you also what an option is. You can add a cast to int. Okay, this is the kind of help that a human being might provide, that the tool provides, because it has the information and is willing to share it with you. Okay, so there is visualization of data structures. So often I will create PowerPoint presentations to go and visualize the data structure, and the programming environment does it for me. Okay, so there is an object hierarchies available. An object can have sub-objects, and this is being shown. How many of you have seen something like this, where you see an object structure? Okay, so only 2 or 3 students. Okay, so the rest of you haven't seen it, but it exists if you use Eclipse. So again, in the Praxes, I will tell you, okay, do this, do this, do this, and this is going to allow you to visualize the data structure. Yeah.
Sorry, so are Praxes like homework assignments sort of? Like, I'm not there. Like, what are they?
Praxes are a means to do your quizzes.
Okay.
You may not look at the Praxes, or may look at the Praxes. Okay? So they are yet another means to go and learn something. So your obligation is to do the assignments, do the quizzes, Sakai quizzes, and to do give the diary. How you do this, I'm giving you complete freedom, a lot of freedom, which sometimes is bad. Okay? But Praxes are exercises that, and if you looked at my Piazza post, I've told you, please do this to access the first Praxis. I assume you haven't quite done that. Once you do that, you'll get to know exactly what they are. Okay? But basically, they are a formal way to go and help you harness the capabilities of the programming environment. Okay? So the programming environment has all these teaching tools in it which you don't know. And what I've got is a script that will tell you, okay, do this, so that you can look at this command and achieve this purpose. Okay, questions? Okay, so Praxes formalize the teaching through programming environments. And just as there's object structure, there's type structure, even though that is visualized. So you can learn a lot through the programming environment. Okay, so let me just ask a sort of philosophical question. So what do you think are the limits to such help, automatic help? We are trying to automate a lot of things, for good or bad. I don't know if it's good for society or bad for society, but that's the trend. There's automatic driving, of course, now, and there's automation in almost all algorithms. So what do you if somebody was to tell you, okay, I'm going to offer you a job in a company that tries to automate teaching, would you take the risk? What does your instinct tell you? That is there potential of success there? Let's forget whether there's money to be made or not. Okay? Or does it tell you that this is too hard? That we always need humans to help? Anybody have an opinion? Yeah.
I do it.
You do it?
Yeah, for sure. But I think the limitation with a lot of the current programming environments is that they can only to a certain extent infer what the programmer's intent is.
So there's limits, yeah.
Yeah, I mean there are limits.
There are limits.
They don't know what you're trying to do. They can only check against it.
So you're saying you would do it with a little caveat that there may be limits to how far you can go.
Yeah.
Yeah. And anybody want to say anybody? So, but you do think there's potential, right? Why do you think there's? Yeah.
If a person wants to learn something, they will learn it in spite of the teacher's best efforts to get in their way.
Thank you. I shouldn't say, I don't know, thank you, Robert. You spoke in my mind. I absolutely agree. I absolutely agree. People who want to learn will learn. There's a lot of research in teaching where they say, okay, I taught it this way and I taught it that way and I got so much difference. And I don't believe those results, because people who want to learn will learn despite the teacher's best efforts to not make them learn.
A good teacher will facilitate the process,
yeah.
but that doesn't necessarily mean it's entirely structured in a classical sense?
In fact, sometimes the structure gets in the way
Yeah.
because you go to sleep because everything is so straightforward and linear and logical, and you're not having to think and do that. So yes, that's another way to look at it. And I absolutely agree with you, okay? Even though I'm right here, teaching.
You're doing great.
Because I haven't taught you anything so far. I'm just telling you what I will do. We get to look at a technical concept, okay? Also, you know, you look at the class sizes. So this class size is diminished, but we started off with 120 students, and the other class, KMP's class, has started off with 290 students. Okay, 101. Chris Jordan's class has, I think, 300 students in each class. He teaches 1,000 students. So look at how large Berkeley has 1,000 students. Look at how large these classes are that are manned by a single instructor. The only way they can succeed if there is some mechanical aspect to teaching, even the part that you require a teacher for. So if there's a mechanical aspect to teaching, eventually it'll get mechanized. Okay? We just need to figure out how to do it. So, I'm a big believer that tools will help, but but humans are also important. Humans are important for things that tools can't do very well. So you want to sort of see how you can help today, automate that, and then find new ways to help. Okay? So as was mentioned, we've got the local checks that they will do. So those of you who've tried this out, what are the difference between local checks and UNC checks? Yeah.
UNC checks is just going to be like general syntax type stuff. Local checks is what you're going to use for each of your assignments to make sure that it's running properly and to get your predicted grade.
Okay, so local, you said two things. The UNC checks are sort of compile time checks, whereas local checks are runtime checks. Okay, so they execute your program. And as it turns out, at runtime, some compile time information is available. So they often do the same things also. Okay. And you said another thing that local checks is what will decide your eventual grade.
Well, like it helps you see ahead of time.
Right. And UNC checks maybe don't factor into the runtime grade. Actually, that's wrong. Okay. So there are some things, I said some compile time information is available at runtime. So local checks will do that checking, but some are not available. So if I want to make sure that you haven't used a library that is banned, runtime checks can't figure that out. They don't know whether you used it tokenized or you used the index of operation in string or you wrote your own index of operation. That the runtime, the UNC checks will look at. Okay, so please try to get all the errors off from both checks. Otherwise, you will lose points. Okay? So together, and because the UNC checks are compile time checks, they're like somebody sort of standing over your shoulder and telling you this is where you've gone wrong, this is where you're right. Okay? Whereas runtime checks they're executed only when you're ready to execute the program. They're much later. Okay? So both are important. That's why we're emphasizing them, but they're not required. If you are pretty sure about your program, you write your own test cases. You go and look at all the requirements carefully, you look at the rubric and validate that everything is as desired. You don't have to use them. Okay? But these are just optional tools that are available for you. So they basically warn against requirements not met, both of them, and indicate potential sources of error. And the UNC checks, we've got this in much more detail later in another slide deck. So this is something you run from ECLIPSE. They integrated within ECLIPSE. And they tell you things like, you haven't declared a method called process input that returns void. Now this is something I can check at runtime or I can check at compile time. Okay? So, but at compile time is telling you, okay, this is something missing. So you say, okay, I've got to do this. So you look at that, then you write process input, and it says, sorry, process input should be calling the scanner. So you aren't calling a scan routine. You say, okay, let me add that. So it's basically there telling you what steps are required to go further. Okay? And in Friday's recitation, hopefully Kent will take you through a path where we'll take some we'll gradually evolve a solution towards the correct solution and see how these results change. Okay? Now, there are two kinds of messages here. One is saying, look, something is missing. The other is saying, hey, I found something that I expected to find. Okay, so it says, I found a class called assignment 1 that you're supposed to implement. So that's good. Don't get, when you see a good message, that's an info message. Info messages are good messages. Warning and errors are bad messages. Okay? So it's telling you both what you're doing right and what you haven't done. And you get some messages right in the editor pane, and some you get in the problems pane. Okay? So there's the problems pane where you get all the compiler warnings and errors. In that also are the check style messages. Okay? Again, this will be a little clearer when you start using this stuff or when Kent demos it on Friday. Okay? And each assignment has a checks file associated with it that checks for that assignment. Okay? So that's something that I mentioned in the check style documentation also. And if you're curious, you can go into the checks file and just look at them. Okay? So all the assignment specifications that I have in English, I'm translated into a computer understood form. And you'll probably, if you look at it hard enough, understand what the language is really trying to say. Okay, but you don't need to. But there is a pattern that I expect many of you will be able to find. Okay, and some of these things, messages will have a EC after them saying it's extra credit. So it's okay if you're not doing extra credit and you get a message saying, sorry, this extra credit function not defined. Say, okay, that's okay. I'm not doing extra credit. Okay, so you'll see things like that in the checks file. Okay, runtime local checks. This is the one that actually tests your program at runtime. It uses both information provided at compile time and the runtime checking. And like was mentioned that you'll find this tool. And this is something to run in Eclipse. You don't have to go to a server to get the results. Okay. Now, here also you'll see a message saying compute angle not equal to correct angle, and you might sometimes get a null pointer exception there. So, writing these checks is not easy. Writing any code is not easy. Writing these checks is not easy. Okay? So it's possible that there'll be mistakes, that you'll have correct code, and we'll say incorrect results. So please let us know. Okay? And also, more important, when your code is not correct, it can be not correct in many, many ways. And we haven't anticipated all those ways. So sometimes we just throw a null pointer exception saying something unexpected happened. So at that point, contact us, but also look at the console. In the console, the checks are saying, I'm trying this now, I found this right, So you'll be able to see at what point the check was when it failed. Okay? So do look at the console, try to understand what's going on, try to help us before you come to us and say, hey, I don't understand why I'm getting this message. Okay? Also, and this is something that hopefully we'll have working this time, but I don't guarantee it. Like I said, your eventual grade will depend on both check style and local checks working correctly. So the integrated grade, which combines both these things, are available through a grading server also. So if you have trouble installing things, and if the server works reliably, server is working, but it crashes often, and it's very hard to debug something like that. But this is something, again, that will be demonstrated on Friday, hopefully. You can go to the grading server and get an idea of the automatic part of your grade. Your grade depends on human grading, local checks, and check style. 3 different things. The human grading will happen only when the humans grade it. Okay? The other 2 parts combined together can be accessed to the grading server. And how that's accessed, there's a PowerPoint that I have on grading server, and again, Andrew during the recitations will hopefully demonstrate that to you. Okay, so these are the tools available for checking, and it'll give you a result like this. Okay, it'll tell you, okay, here are the requirements, here's how many points you got for all of this stuff, and so you can even get an idea of the automatic part of your grade. Okay, you can get points now, not just yes or no, but just points. Okay. So let's come to now Object Editor. So what's the problem that Object Editor tries to solve? If you notice, I layered the concepts and I said, you know, there's a dependency. And number 7 is UI toolkits. That means UI toolkits you can't look at, understand really unless you've done 6 different things before that. Okay. UI toolkits are what allows you to create a GUI to your application. Now, what do you do if you're going to? So what if? So you know. So what do you do if you have this dependency? Well, you can say there is no GUI. There's only this console-based UI to your applications, but the application I've chosen does have, you know, is a graphical application. It's a little virtual environment in which you move avatars and shapes. So that is, you know, I'll have to change the assignment completely, and to have an assignment with no UI or at least no graphical UI seems very backwards. Okay. Some people just have console-based UIs, but it's just not satisfying. It's not modern. It's and you don't visualize things as well. Those of you who did Comp 110 with Chris Jordan, you guys had UIs, but what was that? He provided you with the UI code, and you fit your code to his UI code. Is that right? Okay. So you had to fit it exactly. I mean, you couldn't. There was only so many choices you had because he called methods in your code. So there was very little creativity in, for instance, to display an avatar. Okay. So in our case, so and he wrote a piece of code that was very assignment specific. Okay. So if he was to change assignments, he would have to change his code. Okay. So that's another alternative. Okay. But again, given that I want to encourage creativity here, that doesn't quite work out. Okay. And why use some code that is assignment specific? Why not create some more general tool? Okay. For those of you who did 401 with KMP, what he does is he doesn't have a UI for most of the initial assignments, and then he goes and adds a UI to these. So that's another alternative we could have done, but you do need to visualize your data structure, at least in the projects that I have in mind. Okay? So that is the problem, and the solution is that it's a sort of hybrid solution between KMP's and Chris's. So what you will do is you will get an automatically generated UI that is not assignment specific, that just takes an object. If the object is coded using well-defined rules, it'll create a UI. Okay? So you have a UI for free. And that UI you can change with your own UI without changing any part of your code. In fact, this code doesn't even have an API. It just looks at your code just like a grader does and understands it and visualizes it and creates a UI. Okay, so eventually you'll be like KMP, you'll be building your own UI, but you'll be replacing an existing UI with a new UI. Okay, so that's what Object Editor does. And you know, the one complaint people say is, but it's undocumented. And that's kind of true. It has only one API line. You say object editor.edit object. That's it. Okay, and it's hard to sort of forget this line. Okay. So what is undocumented about it? Well, the fact is that it requires you to follow certain style rules to create the UI. These are the same style rules that are needed for a human being to understand your code. So we are not talking about inventing new style rules. Well, sometimes we have to because those style rules don't quite exist in the literature. Okay, but you have to follow some conventions. Okay, and as long as you follow these conventions, and these conventions are taught for each topic, then the object will be displayed correctly. Okay, and you'll often find, you know, people come and say, but my program works, you know, it's object editor that's getting in my way, or it's the local checks getting in my way, or the UNC check style getting in my way. They're just the messengers. They're telling you what you're doing wrong so that you can correct them before you get your grade. Okay? So the whole idea is to go and write code that is structured well enough that a tool can understand it, and if a tool can understand it, a human being can understand it. Okay? So that's the goal we are looking at. So keep remembering that how you program is very important in this class. Okay? It's not just input-output. Okay? And these are just tools that help you. Okay? Now, how the object is visualized as OE specific. There's many ways to visualize a data structure. You're not graded on how the objects are visualized. You know, the fact that you can visualize it is important for us because it means that we could understand your code. Okay? And an API exists to go and modify the visualization too. And a lot of students want that. They want it to look pretty. And I say, okay, here's the API. You don't lose points if you don't make it, if it remains ugly, but you have a choice. Okay? So what I've done is all the rules that it uses. I'm going to be in trouble here. So I better. I'll go very quickly. Actually, I'm. Okay, so I've been talking about research tools, about all of these tools. So even when Microsoft, with its thousands of engineers, produces software, or Google does, you find oops or blue screen. So software will give you trouble. Okay, and already I have a student here who's shown me that his output program seems to work correctly, but local checks is complaining. So, so these things can fail and they're optional. If you find them not worth it, don't use them. Okay, but I think you'll find them worth it. So there's none of the tools is really required. Object editor is kind of required. So some of your assignments require you to have the instructors to do some visual grading. Okay, so they look at the UI and try to figure out whether you did the right thing. And they look at the object editor UI. Because if you don't have a UI, you have to look at the object editor UI. So to that extent, object editor is required. Otherwise, even object editor is not required. So don't feel that you come to this class and you're being forced to deal with things that are quote unquote non-standard, because they're research tools, they're non-standard. So this is it's just an option. Okay? And because it's research, who knows what interesting things I might discover through these tools. Okay? So what you'll find is a consent form when you download things, and